All right, guys, I'm sorry that last one cut me off. But we're giving these functions different names, so when we graph them, okay, we can just write their name by it, f of a, or I mean f of x, g of x, h of x. They're just different names for the function, okay? But do you see that I just took the y away and I put that f of x in there? Now here's something that is very important. It's so important that I'm cupping my hands around my mouth to make my voice louder, okay? That does not mean f times x. Please do not mistake it for that. It does not mean f times x. It means the function of x. Now g of x, you know, we can't really say that g stands for function, but I need a different name, so I call it g of x or h of x. It does not mean multiply g times x, okay? It means the function of x. F of x means here's what the function of x is. We multiply it by -1/2 and then we add 2 to it. That's the function of x. In this second one, the function of x is that we multiply it by 3/4 and subtract 7 from it to get the y. Okay? The y and the f of x, these two things are interchangeable. I can take f of x out and stick y in its place. I can take g of x out and stick y in its place. The reason that I've given it these different names is because I have different functions. Okay? So I can tell the difference between them. It's like saying y2 and y1. They're both y's, but they're not the same y. So I give them different names. I give one y2 and I give the other one y1. Well here, these are all functions, but they're not the same functions. So I take the y out and I give them a name. F of x, g of x, h of x. I'm sorry, figure that out, Sophia, and I'll talk to you later. Okay? Now, I'm just getting, well, I don't need to get rid of that. Okay? Now, Parker, let's do example 1, and then I'm going to talk about some stuff graphically too. Okay? Parker, in example 1 it says, decide whether the relation is a function. If so, give the domain and the range. Okay, well remember, input, the collection of the x's, that's called the domain. The collection of the y's, or the output, that's called the range. And I already wrote it here above that for you. Okay? But let's look at this first one. If I stick in 1, I get 2 out. If I stick in 2, I get 4 out. If I stick in 3, I get 4 out. If I stick in 4, I get 5 out. Okay?
Those all work.
Those all work. That's okay.
Yeah.
So yes, this is a function. Okay? I'm sorry. Hang on a moment. This is a function, yes?
Yes.
Now it says, if so, give the domain and the range. Okay, well the domain for the first one is what? And I'm going to put D, and I put little braces here. That's the way we normally write it.
All right.
So what is it?
1, 2, 3, 4.
Exactly. Domain is what we stick into the function. All right?
Then the output, then the range is
Yeah.
2, 4, and 5.
Exactly. That's exactly right. Okay? Now, Parker, let me explain something to you, and I may actually have to start another video with this thing. Think about this. If I ask, I'm going to ask Parker J. Parker J, are you in the 8th grade?
Yes.
Okay. Parker A, are you in the 8th grade?
Yes, I am.
Okay. So that was 2 different questions, right? 2 different inputs gave me the same output. Is that okay?
Yeah.
Okay. Now let's just do one input. James, are you in the 8th grade? He is. He cannot say yes and no. That doesn't make any sense. He can't give me 2 different outputs, right?
Yeah.
He can only give me one output. All right? One question can only have one answer. Questioning 2 different people, they can give me the same answer. They can give me the same output, right?
Yeah.
But one question can't give me 2 different outputs. It doesn't make any sense. Okay? So let's look at this next one, and this is going to cut me off. Now, is this one a function, Park?
No.
It's not. Why is it not?
Well, 1 is all equal to both 5 and 7.
Exactly. 1 cannot have 2 different outputs. This is not a function. It is a relation. I don't know what it means. Okay, but it's not a function. All right. What's the domain, quickly, Parker?
1, 2, 3, 4.
1, 2, 3, 4. And Parker, what's the range?
5, 7, 9.
5, 7, and 9. Excellent. All right. Let's look at the next one.